to order 2 raised to the 100th power, 3 raised to the 75th power, and 5 raised to the 50th power from least to greatest. Again, by the way, we're slowing down our little vacation, okay? This is still pre-algebra exponents. So, you see these exponents here? I can think of the 3 main rules and strategies you can use to solve exponent ordering problems like this one. First of all, this is funny. I'm gonna just compute every single one. No, so just about every problem, they never want you to actually compute every one of their asks or what they want you to get. So definitely not this one. I think we mean this one. So 2, we focus on the base. So I'm gonna write down focus, and then we focus on the base. So here's an example. If I had 7 raised to the 6, and I had to compare 8 raised to the 6, I see the exponents, they don't really do a whole lot, right? They're the same. So I see 7 and 8. I'm gonna focus on these because 7 and 8 are different. So I multiply 7 6 times and 8 6 times. 7 raised to the 6 is definitely smaller than 8 raised to the 6. And here, this time our focus will be the complete opposite. I'm gonna focus on exponents. Write this down. Exponents. Just a little small vector. Okay, take this. And here, we're gonna take 9 raised to the 12th. And then we have to compare that to 9 raised to the 16th. So these 9s, they don't do a whole lot, right? Again, just like a pair, they're the same. So it's the same, they don't tell us anything, right? They're just equal. So here, we compare to 12 and 16. But multiplying 9 12 times is definitely, again, smaller than multiplying 9 16 times. So these 3 main strategies, we can combine them here to solve this problem. So first of all, definitely not computation, since who will want to compute 2 raised to the 100th power? Since how do I even know if I multiply the 2 100 times? Since don't even think of the computation, just how do you make sure that you multiply it the right number of times? That's definitely not computation. So now I have 2 more strategies, and both of these require the base same or all the exponents the same to make one of these strategies works. So first of all, let's try to get our base the same. So first of all, first things first, these are prime numbers. You can't possibly break them down into something like 2, 5. You can't break them down and things like that, since these are prime numbers. So you can't break them down. So what about if we multiply some of them? Oh, I can get the common factor of 30 and multiplying 2, 3, and 5. So somehow I might be able to get it all the way to 30. So if for this 2, I can multiply 3 and a 5 to get off 30. And 3 for the 3, I have 2, and 5 for the 5 finally, I have 3 and 2. But if I want to keep all those, if I want to keep saying that this will be the same, that my final equation will be the same as comparing these, I'm gonna have to multiply all these bases by the same numbers. But what we were doing, it wasn't the same, since for the 2 I had to multiply 3 and 5, but for the 3 I had to multiply a 2 and a 5. So this is definitely not gonna end up equal to this equation, to our the 3 numbers we're gonna have to order right now. So if you can't break them down, you can't multiply them together, we're definitely not gonna be able to get our base the same. We're definitely not gonna be able to do that. I'm gonna punch running a little out of space. Anyway, so if we can't get our bases the same, let's see if we can get our exponents the same. So I think this is actually going to work. Let's put a check mark here first, just out to work. So I can put this 2, I can put it, make it as 2. And see all these, before we do all this work, we have to see that 50, 75, and 100, they're all multiples of 25. They're all multiples of 25, right? So if they're multiples of 25, I'm going to split all these exponents up into multiples of the 25 times something. So I'm going to split this 100 up first into 4 times 25. So this is definitely going to be the somewhere. This is going to work, definitely. So now we have the 3. Yeah, we're going to split the 75 up. What are we going to do it now? Yeah, 3 times 25. It's the same. It's the same of the 50, of the 5. And then we split that up into 2 times 25. And then with that, all you know about exponents, that video before, we can change this. You can change all these into this. Into all these. We put this in. You remember that technique, right? You still remember that. I hope you do, because that's gonna come in use today. Okay, wait, parentheses. Oh yeah, that thing about parentheses are very important. That goes in use here too. So put the equal sign. Gonna have 5 squared. Raise that to the 25th power. So now, finally, you can compute each one of these. So here, 2 raised to the 4th power, that's 16, raised to the 25th power. Okay, now we have 3 cubed. 3 cubed is 27. And then we raise that to the 25th power. 5 squared, it's not quite 27. Still, it's only 25. Cool, 25, 25. So I just want to point out 2 more things. So first of all, now I can order these with rule 2 of come back here. Since our exponents are the same, so all I have to do is focus on our bases, which is the 16, 25, and 27. So another thing, we don't want to order these. We want to order these the problem gave us. So we see 16 25ths. Well, that's the 2 raised to the 100th power. That's the least. And then for our median, we have 25 raised to 25th power. That is the 5 raised to the 50th. And finally, for our largest, we'll have the one we already circled. This is equal to 3 raised to 75th power. 3 raised to the 75th power. And there we have it. This is our true answer.